Hi there, welcome back to the channel. In this video, I'll show you how to plan a 2D drone mapping mission using the DJI RC Pro Enterprise controller and the built-in DJI Pilot app. We'll walk through the full process step by step, and for this example, we'll plan a mapping mission over a sporting complex. This workflow is perfect for creating orthomosaics for surveying, planning, and GIS work. Let's start with the controller. It has a bright built-in screen, physical buttons, and enough processing power to run the DJI Pilot app without needing a tablet or phone. Everything we need for mission planning, flight execution, and data capture is already built into this controller, which makes fieldwork much easier. Once powered on, the controller launches the DJI Pilot app. This is DJI's Enterprise flight app designed for mapping, inspections, and automated missions. The controller is basically an Android device. If you click the back button, you will be at the home screen. There you can see the app and access features such as gallery and the device settings. Let's get back into the app. For 2D mapping, we'll be using the map or flight route mission mode depending on your drone model. From the main screen, tap flight route. This should bring you into the mission library. All your previously planned or mission history can be found there. Click the add or plus button on the top right corner of the screen and select create a route. Select the area route option. This option is for both 2D or 3D missions. This mode automatically plans a grid flight pattern designed to capture overlapping images for photogrammetry. Now, let's locate and set up our mission over the sporting complex. First, we define the area we want to map. Using the map view, I'll zoom into the area and draw a polygon around the sporting complex. To draw the polygon, you simply click on the screen to mark its boundary corners. Make sure you cover the full area of interest, including a small buffer around the edges. This helps avoid gaps in your final orthomosaic. Once you're satisfied with the polygon covering area of interest, you should now have an estimate size of the area. This is displayed next to the blue tick button on the top left corner of the screen. Click that button to continue. The app now asks you to select the aircraft model that you will be using for this mission. For this example, we use a Mavic 3 Enterprise. Select the appropriate aircraft and camera model and then click OK. This brings you into the important part of mission planning, where you will be inputting your flight parameters. First, go ahead and give your task a name. After selecting your aircraft and camera model, notice that on the left side of the screen, a flight path shown in green has automatically been generated with predefined parameters. You will have to fine-tune this according to your site and task requirements. Now on the right menu, make sure ortho collection is selected. For this example, we will type in 60 meters as our route altitude. Flying at this altitude improves our ground sampling distance, or GSD. When selecting your route altitude, make sure you are familiar with the site and its surroundings. Ensure there are no towers or buildings above your selected altitude to avoid crashing your drone. You can leave elevation optimization enabled to increase elevation accuracy. Other settings you have control at this stage include the speed of the drone and the course angle. The maximum speed by default is based on the aircraft and camera model you selected. You could go with the default max speed, or if you have time and extra batteries at hand, you can lower the speed and let your drone go for a cruise. For the aircraft course angle, you can slide the bar to adjust. It's always a better option to choose an angle where the drone flies back and forth from where you will be stationed, or easy for you to bring back in case of emergency. Now, if you click on the advanced settings, you can now adjust for image overlap and also margins or buffer of the site. Set overlap according to your site's appearance or software recommendations. In the advanced settings, you also have control to set where you want the drone to start the mission. You can do quick cross-check on all the settings. Once you're satisfied with all the input parameters, you can now go ahead and click the Save button on the top left corner of the screen. This mission is now stored in the mission library and can be executed once you are on site. Before we wrap up, here's an important bonus tip. Understand altitude modes in DJI Pilot 2. Choosing the correct altitude mode is critical for safe flights, accurate mapping, and consistent data. First is relative to takeoff point, often shown as ALT. This mode measures altitude relative to where the drone takes off. So if you take off from ground level, flying at 60 meters means the drone stays 60 meters above that launch point. If the terrain rises or falls significantly, the drone will not adjust its height, which can affect image quality or clearance. The next mode is ASL, or above sea level, based on the EGM96GOID model. Here, altitude is referenced to mean sea level, not the takeoff point. This is commonly used for aviation coordination, airspace management, and integration with other elevation datasets. Key thing to remember is that ASL is not terrain aware. The drone still won't automatically follow hills or slopes unless terrain data is applied separately. The third and most advanced option is AGL, above ground level. In this mode, the drone maintains a constant height above the ground, even as the terrain rises or falls. This is especially useful for corridor mapping, hilly terrain, and uneven landscapes. What makes AGL powerful in DJI Pilot 2 is real-time terrain following. Using global or locally available elevation data, the drone dynamically adjusts its altitude during flight to maintain the set AGL height. For example, if you set 60 meters AGL, the drone will continuously climb or descend to stay 60 meters above the ground surface. Choosing the right altitude mode can make a big difference in safety, data quality, and mission success. If you found this bonus tip useful, hit like, subscribe, and stay tuned for more DJI Pilot 2 and drone mapping tutorials. Thank you for watching, and see you on the next one.